Sometimes with triangles there's two solutions, there's two possibilities that would fit this information, having an angle and having two sides. Sometimes there's only one triangle, sometimes there's 0 triangles that are possible. So let's draw out this triangle, what it could possibly look like. And I didn't make it a right triangle that we usually see in a trig class. I mean, we should see everything in a trig class, but right triangles just come up the most. Let's say this is 68 degrees, that's angle C, and then side C is 15, so the side opposite of C is 15, and B is 22. Since we're not guaranteed this is a right triangle, we can't directly use sine, cosine, tangent because there's no guaranteed hypotenuse. This might be the hypotenuse, it might not be 90 degrees. So instead what we have to use is another tool called the law of sines. And I've got the formula up here for us. The law of sines says that if you take sine of an angle and divide it by its corresponding side, that should equal the sine of a different angle divided by that angle's corresponding side. So you can compare any of these pairs to each other's. So we have a complete pair. We have an angle and its corresponding side. Oh, that should be a C there. Sorry. We have sine of 68 over 15, and that should be equal to, now it looks like we have some information about B. That should be equal to sine of B divided by the corresponding side length of B. And so to solve, we could bust out our calculator, keep it in degrees, and then type in 68, trig sine for the top, that's 0.927 divided by 15. So the left side is 0.0618. And if we multiply both sides by 22, 0.068 times 22, that gives us 1.359. And actually all that rounds up to 1.36. So normally what we do to get B by itself is we'd use inverse sine, but the problem with that is back here from our previous study of trig functions, the amplitude here is 1. That means sine of B has to be somewhere between -1 and +1. So sine of B equaling 1.36, it can't happen because this trig function, sine of x, fluctuates between -1 and +1, never goes up as high as y equals 1.36. So 0 triangles are possible here. So let's draw what we've got here. Got angles A, B, and C, just throwing them in there. They don't necessarily have to look perfect. 44 degrees, and the corresponding side to capital A is 24. We don't know what C is, but we know that this is 28. So we have an angle and its corresponding side. That means the law of sines is going to help us out. That should be equal to sine of C over its corresponding side. Okay. Sometimes you'll see this as lowercase a over sine of capital A. That'll do the same thing. Okay, so we have an equation to solve. We can convert this. Well, actually, let's save ourselves some trouble. Let's just multiply 28 to both sides, because those will cancel. So this is what we got to really type in our calculator. I'm going to type 44 sine multiply by 28 and then divide by 24. So we got 0.81. So that's possible, unlike the last question we saw. Right? Sine of C can equal 0.81. So let's see. What you want to think about is, remember when we studied before where sine can be graphed, like we said that sine could be positive here. So it could be a positive 0.81 here. It could be a positive 0.81 here. So we can solve for one of them with our calculator, but you'll want to be careful because the calculator is going to miss the other one. It's only going to give you one output. Right? Because if you do sine, inverse sine of 0.81, we get 54 degrees. So this is roughly 54 degrees. And then over here, if we were to do the same ratio, look, it's the same triangle. If this is 54 degrees over here, then 180 subtracted by 54 gives us 126. So a sine of 126 should do the same job. Let's check too. 126 trig sine, that also gives us 0.81. So just watch out for that. With the law of sine, sometimes it misses another possible solution. Think about this answer. With what we've studied already in this trigonometry class, we know that we can draw that triangle in two different places. Sine is a positive value in first and second quadrant. So using reference angles, if this is 54 degrees, you can subtract that from 180 to find the other one. So this can be either acute or obtuse. One of the angles is 54 degrees, which we got from a calculator, and the other angle we got was 180 subtracted by 50. It was 126 degrees. That would make it an obtuse triangle.